well, welcome everybody to the live stream tonight. I do want to say I'm sorry to all the subscribers and viewers of some of my content. It has been a while since I've been able to post anything. Basically from like middle of June, I have been extremely busy with family things and commitments that pretty much have taken away a lot of time that I could dedicate to the channel. So I'm going to try to get back into making some regular content, and I do want to say I appreciate everybody sticking around. I do want to say thoughts and prayers go out to all the everybody's family and loved ones down in eastern Kentucky, Hindman, Kentucky area. My father-in-law is actually lives in Hindman. In June, we actually had to go down and visit with him for a family event that we had to go down for, and it's been a pretty trying time down there, and I know it's been a pretty trying time for my wife, talking with her father every night, making sure things are okay and what needs to be done. So I hope everybody's families are safe that are down there, and hope everything kind of works its way out. So as far as amateur radio, ham radio stuff, I've been a little preoccupied, like I said, so I haven't been into much of my projects or things I've been working on. Didn't get my satellite tracker up and running fully like I wanted to for field day. It is the pan and tilt assembly net does work the way I've got it set up. Getting the Arduino sketch to cooperate has been a little bit of a trying. It's been getting the best of me, and haven't got that fully operational there to where it's fully automated, but some tweaks and changes, and I think it will. I'm actually looking into a little change in design and beef it up a little more, and potentially change from servos to stepper motors instead, and maybe that'll gain me some little bit of gear ratio, along with probably 3D printing some worm gear type gear ratios and that, and implement it into the design as well. So some version 2 being in the works, some other things I'm working on, obviously with the 3D printing of a bunch of different items. I'm kind of redesigning some stuff I've made. Recently have changed out the motherboard and screen version on my Ender 3 Pro. Got it up and running with the 4.2.7 silent motherboard. Big difference there on the noise reduction on the stepper motors and everything. Still working on getting that to work fully correct. It's not cooperating with the current firmware that I have for it. It's got a little bit of glitches in it where it's not fully cooperating. Either the new V2 screen doesn't want to work with it, or the CR Touch that I've got installed for the bed leveling is kind of throwing off a little bit. So that's some more to tweak in there to get that up and running up to par. Like, I'm happy with the prints. Started doing a WinLink node using a Raspberry Pi. I've got the Pi all configured and set up now. I'm kind of working with the TNC and radios. I got one or two mobile radios that I want to try to see if I can get it to work with, and have a 24/7 365 WinLink node operational. And thoughts on there is also 3D print a frame that is a modular frame, so it'll kind of work with about any radio or setup. They could almost put in a backpack and take with you. So that's some more stuff I'm working on there, as well as recently acquired my GRMS radio. This is a Baofeng UV9G that I picked up. So I've got my call sign in that for GMRS also. So, well, good evening, Bill. Glad to see you join here, and just kind of going through some formalities and then get into some more of my questions. So a little bit of stuff on the horizon, so kind of all coming together slowly here now that maybe time will kind of free up some and get back to doing some more content on the channel. So thanks for all of you guys support and sticking around. And with that, let us switch over. There we go. Some more of the 2020-24 extra class questions going through. Probably will do another 10 to 15 questions like usual. And just going through the question pools. I did get some comments on one of the videos since I'm teaching extra class, asking me something about, I'd have to look back at the comments, but I'm not really teaching the class. I'm just kind of going through questions and sharing that with everybody as I go. But if time allows, I'll gladly try to research and look up some information. So without further ado, we kind of left off here in, where did we leave off? Receivers with great filters chapter here in the book. So our next question here is, how does a diode envelope detector function? Is it A, by rectification and filtering of RF signals? By B, by breakdown of Zener voltage? C, by mixing signals with noise in the transition region of the diode? Or D, by sensing the change of reactance in the diode with respect to frequency? Not going to really take a guess on that one. I'm not totally sure. I'm learning as we go. So, since a diode only conducts for half of the AC signal, it may be used as a rectifier. By filtering out the radio frequency energy, after rectification, detection is accomplished. The modulated signal is all that remains. So the correct answer is A. So how does a diode envelope detector function? The answer is A, by rectification and filtering of RF signals. And it sounds like my wife is talking with her dad right now. I just got a call from him, so I hope if I turn this highlighter around. So hopefully all is still going well with him down there. I know he's working with FEMA and them now to help him get some stuff cleaned out. So, so there's a little diagram here of a diode detector showing your input, output through the diode, and the RF bypass. So we'll see how that kind of works. So our next question here is, which type of detector circuit is used for demodulating single sideband signals? A, discriminator. B, phase detector. C, product detector. Or D, phase comparator. Sorry. Any guesses, Bill? A product detector is found in single sideband receivers. It mixes the incoming signal with a beat frequency oscillator signal that is a locally generated carrier which is mixed with the incoming signal. So your correct answer is C. So which type of detector circuit is used for demodulating single sideband signals? Answer is C, product detector. And it kind of shows here, product detector circuit used for single sideband. You got your signal from the IF going into your inductor L1. Pretty extensive little diagram here. So for those kind of listening, as I've heard some have done, is almost like a podcast on the way home. They can't really describe this little diagram here, but it would be a good one. So your correct answer is C, a product detector. Alright, last question on this page. What are the principal frequencies that appear at the output of a mixer circuit? A, 2 and 4 times the original frequency. B, the square root of the product of the input frequencies. C, the two input frequencies along with their sum and difference frequencies. D, 1.414 and 0.707 times the input frequency. The mixer produces your original two frequencies and the sum and difference frequencies. As seen in the illustration on the top of the next page, The more elaborate the transceiver, the more mixing stages in the set. Mixing stages help filter out unwanted phantom signals that could cause interference. Correct answer is C. So what are the principal frequencies that appear at the output of a mixer circuit? Correct answer is C. The two input frequencies along with their sum and different frequencies. Difference. I should emphasize that. Get the page flipped here and kind of see if we can see this diagram a little bit here. So frequency, spectrum, plot, and mixer signals. Kind of shows a little bit of a diagram here. You got your signal amplitude here at 5 megahertz, showing, and then the signal amplitude at 9 megahertz, and then your signal amplitude for the differences. For your difference is 9 megahertz minus 5 megahertz equals 4 megahertz difference frequency. And then your 9 megahertz plus 5 megahertz, 14 megahertz sum frequency. So your mixer output is basically gonna, those are your four that it's gonna focus on. Hopefully I didn't confuse that up too much. So moving on to our next one. What occurs when an excessive amount of signal energy reaches a mixer circuit? A. Spurious mixer products are generated. B. Mixer blanking occurs. C. Automatic limiting occurs. Or D. A beat frequency is generated. Some VHF power amplifiers incorporate a hefty preamplifier circuit for use on receiving that boosts incoming signal levels. When the preamp is turned on, it could generate spurious mixer products as a result of high signal level. Spurious products are not signals that you want to receive if you use a handheld with power amp. Turn the preamp off to avoid these unwanted signals. So your correct answer is A. So what occurs when excessive amount of signal energy reaches a mixer circuit? A. Spurious mixer products are generated. So whereabouts are you at Bill? I see you got a Kilo Foxtrot 4 call, so you're probably, I know you're going to be in that Central Time kind of, or just east of the Central Time. You're right around in the mid. Oh, Louisiana. Okay, that does stretch all the way south there. And hopefully the weather's been pretty cooperative down there for you guys. I don't recall seeing any impending storms given the season. Oh, I moved from Florida. Yeah, I'm all the way up here in New York still. Kind of working out with the family to try to see, now that my son graduated high school this year, he's off to college. So I've been talking with my wife about possibly relocating out of New York. Just not sure yet. So, moving on to the next question here. Which of the following signals might a receiver noise blanker be able to remove from desired signals? A. Signals that are constant at all IF levels. B. Signals that appear across a wide bandwidth. C. Signals that appear at one IF but not another. Or D. Signals that have a sharply peaked frequency distribution. Yes, yeah, I know when I was stationed in Virginia, I was always on call to go out if the storms are coming in, and I was actually going to head down to the Gulf for a little while, and then they canceled those orders for emergency response. So the noise blanker works best on repetitive correlated wide bandwidth noise like spark plug noise, motor noise, pesky home light dimmers. However, the noise blanker will create phantom signals on your receiver frequency from stations on nearby frequencies, or create distorted reception to very strong on-frequency stations. Turn the noise blanker circuit on your station whenever possible. So the correct answer is B. So which of the following signals might a receiver noise blanker be able to remove from desired signals? B. Signals that appear across a wide bandwidth. So, kind of. Okay. Next one here. Which of the following types of noise can often be reduced with a digital signal processing noise filter? A. Broadband white noise. B. Ignition noise. C. Power line noise. Or D. All of these choices are correct. And I think that the correct answer here, if I'm not mistaken, is D. Most high-frequency transceivers now include a digital signal processing filter. This filter will magically subtract broadband white noise, help minimize power line noise, may cancel out steady frequency heterodyne signal, and help to reduce ignition noise. All of these may be addressed with a DSP noise filter. But, we always recommend solving the noise problem at the source rather than trying to mask it or subtract it with DSP. So the correct answer is D. So which of the following types of noise can often be reduced with a digital signal processing noise filter? Correct answer is D. All these choices are correct. So that includes power line noise, broadband white noise, ignition noise, and and even cancel out a steady frequency heterodyne signal. So a DSP is good to help subtract all of that if you're not able to eliminate any of that noise by resolving it. So modern high-frequency rigs have built-in adaptive DSP filter options. You have an old HF transceiver, you can add an external amplified DSP speaker and dial in your own level of noise elimination. So it kind of shows an external one to add to your let's see, how long have we been trying to see how long we started? About 6:30. All right. Next question here. What is one type of electrical interference that might be caused by nearby personal computer? A. A loud AC hum in the audio output of your station receiver. B. A clicking noise at intervals of a few seconds. C. The appearance of unstable modulated or unmodulated signals at specific frequencies. Or D. A whining type noise that continually pulses on and off. Personal computers and other digital equipment use a square wave signal called clocks that run at very high frequencies. These clocks can cause problems for radio receivers because they are composed of all the odd harmonics of the fundamental clock frequency. As you tune your receiver up and down the band, you can expect to find these harmonics. They may be unstable because clocks are turned on and off as different operations take place in the computer. They may appear modulated when they are affected by other signals or operations of the computer. If you suspect interference from a digital device, find a frequency where the interference is happening and then simply turn off the suspected device. If the interference goes away, you have identified the culprit. To reduce the noise from such devices, try moving them further away from the receiver or try adding shielding around the device to reduce the level of interference. So your correct answer is C. So what types of electrical interference that might be caused by a nearby personal computer? is C, the appearance of unstable, modulated, or unmodulated signals at specific frequencies. So we'll move right on to our next question here. I was wondering what that what that was for, Bill. I saw something. I was like, well, he might be meaning to chat to somebody else. What might be the cause of loud roaring or buzzing AC line interference that comes and goes at intervals? A, arcing contacts in a thermostatically controlled device. B, defective doorbell or doorbell transformer inside a nearby residence. C, a malfunctioning illuminated advertising display. Or D, all these choices are correct. I think maybe any of them, possibly, the way they're laying that one out. With your new big directional HF antenna taking advantage of your new extra class privileges, you may pick up noise in one specific direction, likely when you're aimed at a local shopping center. All these answers can generate a variety of interference, but may come and go at intervals, just like that flashing neon sign down the street. There's no simple filter to cancel out many of these nuisance noise sources, other than aiming your beam at a point where the noise sources are minimized. So your correct answer is D. So what might be the cause of loud roaring or buzzing AC line interference that comes and goes at intervals? Correct answer is D. All these choices are correct. So examples would be arcing contacts in a thermostatically controlled device, defective doorbell or doorbell transformer inside a nearby residence, malfunctioning illuminated advertising display. So any of them, if you're pointing in the correct direction of the signal, you could pick up as interference on your rig. And the best thing to do is probably rotate your direction slightly off from that to where you're still in a reasonable direction facing where you want to get your best pickup, and where you're off enough to where you may not be receiving those interferences. Next question here. What undesirable effect can occur when using an IF noise blanker? A, received audio in the speech range might have an echo effect. B, the audio frequency bandwidth of the received signal might be compressed. C, nearby signals may appear to be excessively wide, even if they meet emission standards. Or D, FM signals can no longer be demodulated. For mobile applications, a high-frequency transceiver will incorporate an IF noise blanker as well as digital noise reduction, which is part of the transceiver's digital signal processing. Some transceivers offer blanker on or blanker off with no adjustable amount of noise blanking. Others offer variable noise blanker settings. This is better. It is possible for the IF noise blanker to cause very strong signal to sound distorted and may appear excessively wide. When the noise blanker is set to maximum, it also can cause strong signals up to 30 kilohertz away to become chattering your audio circuit on a frequency that is absolutely open. You may be tempted to tell the offending station up frequency that they are splattering, but the actual problem is not their transmitter, but in fact that you left your noise blanker turned on. Excuse me. So correct answer is C. So what undesirable effect can occur when using an IF noise blanker? C. Nearby signals may appear to be excessively wide even though they meet emission standards. And we'll do one last question for the night and kind of move on, because I know there's some other upcoming videos. I believe there's one from the YouTubers bunch for the ham bench coming up, so they're doing a big planning thing. So last question here: what could cause local AM broadcast band signals to combine to generate spurious signals in the MF or HF bands? A. One or more of the broadcast stations is transmitting an overmodulated signal. B. Nearby corroded metal joints are mixing and radiating the broadcast signals. C. You are receiving skywave signals from a distant station. Or D. Your station receiver IF amplifier stage is defective. So, your modern high-frequency transceiver employs filter networks, many specifically tuned to minimize powerful double sideband local AM broadcast signals coming in on your lower ham bands. But don't blame the AM broadcaster just yet. Corroded contacts on your tower or aluminum rain gutters might re-radiate the broadcast station signals. That is why many hams with big towers use multiple insulators in their guidelines to minimize recertification of the broadcast band signals due to corroded metal joints. Answer B. So what could cause local AM broadcast band signals to combine to generate spurious signals in the MF or HF bands? Correct answer is B. Nearby corroded metal joints are mixing and re-radiating the broadcast signals. So there, that finishes off that page, and that's about 10 questions for the night. So we'll call it there and kind of move on to the next questions here coming soon. And I appreciate the couple of us that joined me here live, and anybody that watches the videos after. I do appreciate it. I kind of enjoy doing it, and coinciding with the hobby, playing radio and everything, and the 3D printing I got into to kind of make my own ham stuff. I've still got a bunch of projects I'm working on there for the ham radio, so I'd like to get some of them finished up as time allows here, hopefully, as things kind of ease up a little bit. So of course, work's picking up as things are easing, so and there again, thoughts and prayers to everybody in eastern Kentucky and surrounding areas dealing with all the flash flooding. I know that a lot of it's been receding lately, and I know FEMA and others have been there helping. There again, it's kind of close to home, being my father-in-law's right there in the middle of it in Hindman. So good luck to everybody, and I hope everybody's families are safe. So with that, I'll say 7-3 and get on the air.